Math 1332, Chapter 2, Set Theory, Section 2.1, Introduction to Set Theory, Video 5, Ways to Represent Sets, Set Builder Notation. So far, we've seen two different ways to represent sets. One was called roster method. And the roster method, if I can type, was where we listed the elements in a set in a pair of braces. So for example, we could say something like, we'll say the set D contains the letters M, I, S, and P. But we've also seen the descriptive method, which is where we don't list the elements in a set of braces, pair of braces, but rather we describe them. Now, how can we describe the letters M, I, S, and P? Well, those are the letters in the word Mississippi. And I suppose we could be super nitpicky and change that to a capital M. Well, what is set builder notation? Well, set builder notation wouldn't be good for this particular one, but set builder notation, that's supposed to be a dash. Set builder notation is kind of a combination of the roster method and the descriptive method. It's where you, this is going to sound funny, you describe the elements of a set symbolically. Well, we'll say in a pair of braces. It almost sounds like we're just merging these two together, but the truth be known, set builder notation is very powerful in upper level math, and we would be remiss if we didn't mention it as a way to represent a set. And the best way I can do this is to just show you an example and explain what all the pieces mean. All right. For example, let's say I write this. We'll open up some braces. And by the way, if you wanted to draw an open brace perfectly, it would look something a little more like this. But if you draw them fast enough and often enough, you start drawing them a little bit more scribbly like that. Maybe not that bad, but something like that, which is just as bad. But anyway, here's an example of what set builder notation might look like. We'll say the set of X an element of N such that X is less than 7. Actually, I'm using a slightly different version. Set of X's such that X is an element of N and X is less than 7. That is a 7. I'd like to make it look a little bit better. Okay. So what are all these things that I just drew? Well, let's start with this variable here, which happened to be an X. Wait a second, folks. My apologies for the interruption. But what are all these pieces in set builder notation? Well, the first piece is a variable. And before you start having nightmares about this being an algebra heavy class, it's not. But a variable is simply an object, usually a letter, to represent something that we don't know specifically. It's like when you say, hey, you, and you don't know that person's name, so you just say the word you. It's almost like a pronoun, if you will. But a variable just represents an object that we don't know specifically. So which variable should we use? The truth is we can use any variable we want, but for simplicity, we're going to use the letter X every time. But if it's a different letter, don't panic. What is this vertical line here? Well, this is a symbol for the phrase such that. So how would we read this? Well, when you read a set that is built in, that is represented using set builder notation, you say the following. The set of, which makes sense because we're describing a set. Then you say whatever the variable's name is, usually is a plural. the set of x's, the vertical line is read such that, and then you just read off the rest of it. X, well, let's actually write it out in words. This is the symbol for is an element of, so we could say x is an element of the natural numbers, or we could say x is a natural number. Again, more specifically, we could say x is an element of the natural numbers, and x is less than 7. So again, set builder notation is almost a combination of the roster method and the descriptive method. Roster method in the sense that you're going to write something in a pair of braces. Descriptive method in the sense that you're going to describe the elements once you've named them generically. In this case, the set of x's, such that x is a natural number and x is less than 7. And now that we know what this particular set builder notation is asking for, could we write this in roster form? Can we just list the natural numbers that are less than 7? Well, first you have to know what the natural numbers are. Those are the numbers we count with. So they start with 1. And we want the ones less than 7, so we would stop at 6, because 7 is not less than 7. Now at this point, you're probably thinking, that is a convoluted way to just say the numbers 1 through 6. But again, set builder notation is really kind of critical in upper level math classes. And even though this isn't an upper level math class, we would be remiss to not include set builder notation as a way to represent sets. Let's just take a look at a couple of examples and then we'll wrap up this video. Write the following in set builder notation. First, the set V contains the elements 2, 4, 6, and 8. And B, the set P contains the elements red, orange, yellow, green, blue, indigo, and violet. Let's go in here and put some empty spaces. There we go. All right. So let's see if we can represent these using set builder notation. If we're going to represent set builder notation, you always start it the same way. Always start it the same way. Open up a set, list a generic element, and by default, you can always use the letter X, and then a vertical bar representing the phrase such that. Then you have to stipulate what these elements what conditions they have to satisfy. Let's look at these numbers for a second. If you were to describe them, how would you describe them? They're even numbers, and you would be correct. So we're going to start our set builder notation by saying X is an element of the even numbers. And in a previous video, we mentioned that we were going to use a capital E to represent the set of even natural numbers. All right, but is that sufficient? Can we close this off? No, we can't. Because if we just say X is an even number, where's the rest of them? Where's 10? Where's 12? Where's 14? So we need another condition. What else do these 4 numbers have in common besides being even? Well, there's a lot of correct ways to answer that, but they don't get too big. The biggest one is 8, so they don't get bigger than 8. So we need to put some sort of condition over here that says it can't go beyond 8. We can say X is less than 9. Okay, I want the even numbers less than 9. 2, 4, 6, and 8. Okay, I should say even natural numbers. We could even say X is less than 10, because this would not include the number 10 because 10 is not less than itself. Or we could say something like this. Do y'all know what this symbol is? It looks like less than, but it's actually less than or equal to. So I would want all the even numbers as long as they're less than or equal to 8. 2 is less than 8, 4 is less than 8, 6 is less than 8, 8 is equal to 8. So as you can tell, there's not a unique way to represent set builder notation. Well, sometimes there's not a unique way to represent set builder notation. I'm reaching into the depths of my brain to think if there's any case where there's always a unique way to represent or any example where the set builder notation is unique, but I can't think of one off the top of my head. I would probably just stick with this one, because if I asked you what are all these numbers less than, you would probably say 9. Why can't I put this? The set of all x's such that x is an element of the even numbers, so x is even, and x is less than 11. I can't say that because this set would include the number 10, which is not in our set. So we can't say that. But there are a variety of ways to say the set of all even numbers that are less than 9. So we'll go with that one. What about part B? The set P contains the elements red, orange, yellow, green, blue, indigo, and violet. Could we just say the set of x's such that x is a color? Well, no, because that set would contain all colors, and there's some colors missing here. There's no black, there's no brown, there's no pink. There's a lot of colors missing. So we can't just say x is a color. But do you know what's special about these 7? And you may or may not, but these are the colors of the rainbow. Technically speaking, the colors of the rainbow form a continuum. So there is something between red and orange, probably red-orange. But when you list the colors of the rainbow, they are typically listed as red, orange, yellow, green, blue, indigo, and violet. So, of course, if you didn't know that, then it would be hard to write this in set builder notation. All right, so set builder notation is just a little bit more symbolic way to represent a set. It's kind of a combination of, it's kind of a combination of roster method because of the braces and the descriptive method because you're describing the elements of the set without explicitly listing them.